You're both. I didn't get I literally. Well,
You're good, you're
I
good.
like it.
I like it like
He
this
told me
too.
to.
Because now I can see the board more.
Alright.
Oh,
I'm about to.
So the way I'm doing this unit with you guys is I'm just adding a little bit at a time. So far you've learned how to find the zeros and talk about end behavior and make a sketch. So today is honestly just that, except there's one additional item. And then tomorrow I'm going to add another additional item to the point where eventually we'll have like 4 or 5 items that we talk about when we make the graph and then look at the graph of a polynomial function. So to this point, sitting here today, whether you're done with yesterday's work or not, that's okay. You'll have more time. But sitting here today, you should know how to find the zeros, understand what that means, and then understand the end behavior and what that means, and then be able to make a graph. So we're going to start this problem. Will feel exactly the same. And then at the end, I'm just going to show you the new thing that we have to talk about with our functions and graphs today. So let's get started. If this is a function and I say, let's make a graph, what's the first thing we're going to do? Yeah, and I'm fine if you don't want to talk about the end behavior right away. You do not have to. I know that the habit kind of has been to this point that we talk about that first going into it, but you can do it later too. So let's just jump right in. Like Kennedy said, let's just go factor this bad boy. So remember, we want to take the business end of the function right here, and we want to start factoring it down, setting it equal to 0. What is the GCF of those 3 terms? Perfect. So we're going to pull out a negative. For sure, we're going to pull out a 3 and we're going to pull out an X. Perfection. And then that's going to leave behind what?
Plus 3x minus 9.
Nice job. Well played. That's perfect. And remember that we always have to now set this equal to 0. It's the 0 that makes all of this work. So don't demean that or act like, we could just leave it off of there. It's setting it equal to 0 is why we're doing this. So leave that there. It should hang around. And now we're going to factor even further. So we're going to factor just what's in the parentheses, this guy. And we know that that's just a simple quadratic. So we're going to factor it with a couple of shells like this. And of course, it's going to have a 2x. And of course, it's going to have a 1x. And the signs are going to be one of each. And we have to make a 9 in the back. And in this case, you want to put a 3 and a 3 like this. Because then the balance that you create is you get your 6 on the outside and your 3 on the inside, and 6 and 3 make 3 if one of them is negative, right? And then you want to put the plus on the stronger and the minus on the weaker like this. So again, so far, business as usual. So we're going to find now the zeros, and the zeros, remember, are the 3 places in this case where the graph crosses through the x-axis. So for this one, what do we get?
0.
Yeah, remember, if you have a GCF with an X in it, the graph will interact with the 0 on the x-axis. How about purple guy?
3 over 2. And it would be 1 and 1.
Right. And yeah, and if that helps you, just write it just right away, just 1 and 1/2, just because we're going to have to graph it. So normally I wouldn't care about such things, but here it's practically sensible to do. And then we got green guy over here. And what does he give us? Right. So we can go ahead now and take our axes. Oops, I didn't want to use green for that. And space-wise, I'm going to give a little bit more attention to the left side than the right side, just proportionally, because I've got to go to -3, whereas on the right, I only have to go to 1.5. and then just mark off some ticks. So let's do like -1, -2, -3. And then on the right side, we have 1 and 2. Don't worry about your y-axis because again, we don't know at this point, nor do we care how high or how low the graph is going. This unit right now is not about that. It's just about the general structure of the graph. So we're going to mark them now. So I'll use my big fat dots. I'm going to put a mark at 0. I'm going to put a mark at 1.5, which is right here. And then I'm going to put a mark at -3, which is right here. Now we do need to discuss the end behavior. So if I look back up at the original problem, what can you say about the end behavior?
It's a negative, so it's negative, and then the 3 is odd, so it's different.
Perfect. Yeah, I mean, you nailed it. So the 3 tells us they're different. So we know it's either low, high, or high, low. And then the negative on the front tells us that it goes to the opposite one, which starts high and ends low. So we know already now that the graph is going to behave a certain way. So it's going to have a finish high over here like this. And then it's going to, obviously, inevitably, it's got to come up through here like this. And then it'll finish low down here like this. So end behavior to the rescue. And then from here, just kind of do your best. And man, that graph probably goes way down for all I know. I don't have any idea, honestly, at this point, how far down it goes, but we know that again, we're not going for like perfection. We're just going for a general sketch here. So man, that one just got hit with the ugly stick over there. So there. All right. So if this were a yesterday assignment, we'd be done. We'd pat ourselves on the back and we'd go on to the next problem. Today's, as you saw from the title of the notes, today's new guy is positive and negative intervals. And I think this is really easy. So I'm going to erase some things. Everyone have everything so I can erase a little bit? Yeah. Okay, so I'm going to get rid of some clutter so that we can talk about intervals. So this graph has 4 intervals, and I'm going to color code them for you. I'm going to start with a green interval over here, like this, and I'm going to do another green interval right here, like this. And this is a really vague sort of question, but can anyone tell me what those 2 intervals have in common? They are very good. And that's what we're studying today is now we want to be able to look at a graph and determine over which intervals across the x-axis is the graph's value positive or is it negative. And so you can clearly see that in those 2 green intervals, the graph is above the x-axis. By definition, then, the function we say is positive. We also have 2 red intervals from here to here and from here to infinity. And of course, those are negative. So what we're going to do is we're just going to name them and we can start left to right. I usually do my graphs left to right. Some people always do the negatives before the positives. It doesn't matter to me. As long as we identified, first off, any questions that there are 4 intervals. You see that the graph is broken up into 4 pieces by the 3 crossers, right? So what we want to say first is that the graph is positive over. You want to use the word over in math when you're expressing an interval or it's happening from here to here. You say the graph is positive over the following interval. Now, there are 2 ways to express intervals, and one of them uses inequality signs. So the first interval I'm going to write is I'm going to say that the graph is positive over the interval from negative infinity to -3. I know that that looks like what you're used to seeing as an ordered pair with the parentheses like that, but in upper math, that's called interval notation. And math people, based on the context, would understand that that's an interval that on the left side goes to negative infinity and it ends at -3. The graph is not positive at -3, which is why I have a rounded bracket on this. And that's maybe a different conversation. You will have no square brackets today. So keep everything as just round. When the time is right, I'll explain to you the whole square and round parenthesis things for intervals. But for today, I think all we're going to see are the round ones. So there's another interval that's also positive. So I'm going to write and. And where is my next interval of positivity? From where to where? From 0 Yeah, and you could call it at this point 1.5, 1.5, 3 halves, whatever floats your boat. Maybe for the sake of like, I don't know, for it making more sense, I can put from 0 to 1.5. So I'm saying to someone that my graph is not positive at the endpoints of those intervals because it's not positive or negative. It's on the x-axis, of course, right? But that's how I name two positive intervals. And then I'm going to switch colors and I'm going to name my negative intervals. So now I can say that the graph is negative, or the function is negative over. And again, I'm going to have two intervals. So this and this, right? How would you just define the first interval? And it's sensible. You should always go left to right. I mean, that's a courtesy, whether you do negative before positive, but a courtesy would be to go from left to right, right? So what's the first interval that we see that's red? It goes from -3 and ends at, I agree, at 0. Those are just marks on the x-axis, right? This is all about x-axis. This isn't about how high or how low. It's about how are you behaving as we travel along the sideways axis. And what's the other interval of negativity?
No, 1.5.
From 1 1/2 to positive infinity. If it's a positive infinity, you do not need to put the positive sign, just like with numbers. However, notice with my green interval up above, I had to put a negative sign because negative infinity has to be specified as going forever to the left. That's the new addition for today's notes is intervals of positivity and negativity. So today's, and I've got a couple more examples because there's always going to be like 1 or 2 people that could use a couple more, right? Or 4 or 5 people, I don't know. But that's the new addition is you do it just like yesterday, but at the end you express intervals of positivity and negativity. So let's do another one. Not bad, huh? Easy peasy. All right, our next one is f of x equals 12x squared plus 8x minus 32. ¿Qué tenemos que hacer primero? Es perfecto, sí. Tenemos que dividir todas las termas por 4. Right? When the GCF is just a number like this, what does that mean? It's not going to have any impact on the graph, right? Just FYI. So what we're really doing here is we're just pulling the GCF out to make our lives a little bit easier. This one bears no fruit. So that red number is useless. You can't just throw it away, but it is, it's not going to give us anything. So what's left is 3x squared plus 2x minus 8. And then, of course, you're going to set that equal to 0. If you ever see me leave off the 0, like maybe I did on the last problem, call me on it because I shouldn't be doing that. We should keep the 0 around as we factor. Let's go see if I blew it on the first one. So no, I still had it. So, okay. But if you see me skip it like a lazy bum, let me know. I'll fix it. All right, so now we got to factor the white parentheses. So we're going to bring down the 4, that useless guy. It's, of course, going to be a 3x and a 1x. The signs are, of course, going to be positive and negative. And what's the balance that we want here? It's either 4, 2, 2, 4, 8, 1, 1, 8. I mean, it's one of those 4. I think I like the 4 here and the 2 here. And again, for you guys who maybe are still a little weak on your factoring, you say, why did we do that? Because this makes a 4x. And this makes a 6x, and 4x and 6x make 2x, provided that one of them is negative, right? So we're just looking for that dynamic there. And we want the stronger to be the positive because it ends, the purple circled thing as a positive. So we want to give the strong 6x the positive and the weak 4x the negative, like that. So having said that, remember the red guy, or he's not red anymore, but he bears no fruit. So you can just essentially ignore him or cross him out or something like that. What solution or 0 do we get from green guy? Nice. Which, yes, of course, at this point, maybe acknowledge it as what it really is, 1 1/3. And then how about yellow guy? What does he give us? Yeah, you gotta love those whole number integer ones. Go back and talk. Well, we don't have to go back because it's on the screen. What's the end behavior? It's even, so they're going to be the same. and it's positive in the front, which means we default to up, up. Do you guys remember the P word? What kind of graph is this? What's it called? It's a parabola. Very good. So all second degree functions are parabolas when you graph them. So we're going to go and make our sketch now. And so again, you just need some axes. And I'm going to make marks at the pertinent locations. I'm going to need to go as far as 2 in both directions. So there's 1, 2, and 1, 2. And then I'm going to make my marks. My first mark is at 1 and 1/3, which proportionally is probably right about there. And my yellow mark is at -2, which is exactly there. And this graph will behave as a parabola. So it's going to, these ones are the hardest ones for me personally to draw. So you want to go down, back up. I missed my mark a little bit there, but I'll just fudge it here. Just go make it a little fatter. There we go. All right. How many intervals do you see?
4.
There are 3. So not all graphs have 4. You can kind of remember the number of zeros minus plus 1 is going to be the number of intervals that you have. And you'll figure that out just on your own, even if I didn't say that. So here's my interval that is positive. I like to make my positive intervals green for your educational benefit. And then I have 1 negative interval in the center that goes from here to here. So you'll see, like when I post answer keys for this, that I use a lot of red and green. I feel like it really codes it into our brain. What's what? So let's do it. I can scroll up a little bit and let's do positive first because it comes first. So the graph is positive over, and there are 2 of these. So I want to give myself 2 intervals. And where does it go?
2.
It starts at -infinity. You always got to go left to right with intervals. I don't know if I've said that out loud, but like your intervals have got to be defined on the number line from left to right. So -infinity is where it quote unquote starts, and then it ends, stops being positive at.
That doesn't make sense. What are they?
They're from the x-axis. So if you study just the x-axis as we go from left to right, would you agree that if you're anywhere in this purple, if you were anywhere on that x-axis and you went to find the graph, would you agree that you have to look up to see it? Do you see how this graph just keeps going up forever where I'm moving my pen? Right here. See that? If you trace that graph, don't look at it as going up as much as going left. If you're anywhere on the x-axis where I'm coloring in green, your graph is above you, above you, above you, above you, which means that's called a positive interval. And it is that way from -infinity all the way coming in for a landing until you get to this number right here, which is -2. And while we're at it, let's skip that dumb red interval and let's head across to the other green interval. Where does that interval commence? At 1 1/3. And where does it end? At positive infinity. So as we think about the x-axis, this is all about the x-axis. It begins being positive at 1 1/3. And it ends never. It goes to positive infinity. If you're anywhere on the x-axis in either of those 2 horizontal intervals, the graph will be above you, i.e. positive.
Because you just followed it.
Now there is 1 negative interval in the center. So we say that this graph is negative over the interval, and there's only 1, so I don't need an and this time. It goes from -2 and ends at 1 1/3. If you're confused, you will be confused until you start focusing on the x-axis. This is all about the x-axis. So let me color code again for you. So I'm color coding the x-axis for you. You should agree that if you're in the green part of the x-axis, the graph is positive above you. If you're in the red, it's below you. And if you're in the green over here, the graph is above you. I hope that that makes sense because that's a tough one until you're ready to see it. But it's very simple. You just have to be ready to see it for what it is. Okay, let's do one more. Let's make sure. And then you can have a bunch of work time today. So last one is f of x equals 10 x to the third minus 15 x to the 2 minus 100 regular linear x's. Ay, Dios mío. What do we do first?
Let's see.
Let's GCF that little son of a gun. What is the GCF? Can't get a 10, but you can get a 5. And you can get an x. And then that's going to leave behind what? 2x squared
Minus 3x.
minus good. Let's factor the white thing down. So we're gonna 4 and a 5 probably going to be the candidates here. I mean, like I've told you before, I always start closer together. I'm not going to start with 20 and 1 unless there's something in the problem guiding me that way. I'm just going to go with 4 and 5. And again, the vibe of it is if I put a 4 here, I make 8. And if I put a 5 here, I make 5. And 8 and 5 make 3.
But it's gonna have to be 2x plus 5.
And we do want the weak 5x to be positive, and we want the strong 8x to be negative to give us the correct balance. So the first factor is important. This is not a throwaway factor because it has a variable. What does he give us for a 0?
The 0.
Right. And like I said yesterday, do not confuse the noun 0. That is that's a thing with the number 0. They're not the same, okay? A 0, Z-E-R-O, is a place where a graph, for now, interacts with the x-axis. The number 0 is not that, okay? So not the same. So the first 0 is at x equals 0. The second 0 comes from the green guy. What's that? Negative 5 over 2, also known as... Good job. Thank you, Hugo. Negative 2.5 left over. And then we got the purple fellow over here. Love that guy. Gives us an easy 4. So now, maybe not now. I mean, in a moment, we'll talk about end behavior. I mean, we could have already talked about it before. It doesn't really matter, but we need axes. We got to have a place now to put the stuff. So we're going to make y-axis, and our x-axis looks like it'll be pretty balanced. It looks like it's stronger on the right because we got to go to positive 4. So maybe give it a little more loving over there on the right-hand side. So I do want to go to negative 3. So I'm going to go negative 1, negative 2. It's good. Don't leave a point unguarded. So I know that you football guys, like with your offensive formations, you get this. You don't want to not have a guard up there. So like, I don't want to graph negative 2.5 unless there's a capper to the left of it that says negative 3. I hope that makes sense. So don't leave a point out there in space. And then 4, we got 1, 2, 3, 4, like that. All right, so on notebook paper, that's the setup. And now we go and we make our dots. There's the first dot is at the number 0. The green dot is at the number negative 2.5, and the purple dot is at the number positive 4. Boom. You okay? Can I help you with something? I'd be happy to. Okay, now it's time to talk about the end behavior. And going back to the original problem, looking at those two numbers, the first number is this yellow one. The fact that it's odd, what does that mean?
It's gonna be different.
They're different. They do not both go up. They do not both go down. And then I need to defer to his friend, the 10, and he says, oh, by the way, I got you. There's down on the left and up on the right. So knowing that, we can now complete the graph. So we're going to head down here to our graph, and we know that it ends low, and we know that it ends high, like this. So you can really just use common sense then to piece the puzzle together. That's what I kind of like to do sometimes, is just sketch like that. And then you'd be pretty hard pressed to not figure out what the graph looks like from there, right? It's got to behave this way. So the hardest part, once you get good at the math, you'll agree the hardest part is trying to make your sketches not look like garbage. So ooh, that one was pretty. I kind of failed at the end there. Got hit with the ugly stick there, but we'll make do. And then how many intervals do you see? 4. Good. So I'm going to color code, as I always do, my green intervals above the x-axis like this. And my red intervals are below like this. You do not need to color code, of course. That probably goes without saying, but in case you were wondering, I just do it because this is what I do for a living. So there. All right, let's do it. So I'm going to start with negative this time because it comes first, and I'm a left to righty kind of guy. So there are 2 negatives. So I'm going to say negative over blank blank and blank blank, right? Where is the first negative interval? Define it for me. How far left does this interval go? Right, this interval is negative, so it goes all the way to negative infinity, and it ends when? At negative 5/2. And you can write it as negative 2.5, negative 2.5. I put that because I didn't leave myself enough room to write negative 2.5, so doesn't matter. And where's the next negative interval from where to where? 0 to 4. And again, if you're confused, it's because you're not looking at the x-axis. It's all about what I'm scribbling right now in red. Those 2 locations, or those 2 intervals on the x-axis, are where the graph is doing certain things. And now we need to study the green intervals. So my first one that I encounter, so let's write this out first. It takes like 7 seconds. Positive over. And we do have 2. So I'm going to write 2 like this. What's the first positive interval? Negative 5/2, negative 2.5 to what? 0. And then the last one is from? Done. So that's what's new today, is we're doing what we did yesterday, but now we're mentioning the intervals. And your assignment is on Canvas. I'm going to pause this real quick. I don't know if I published Canvas yet, but I'll publish it. And then once you finish assignment from yesterday, you're going to want to get on with the new one. So